Remind me not to play Google because they will flag me and they will lie. That is exponential equations, and really, I want to try to do this without my calculator. Remind me not to play Google because they will flag me and they will. That's on the video. Oh, no. Exponential equations, and really, I want to try to do this without my calculator. That's I forgot I have to do that. Okay. Sorry, guys, for that. Okay, the first thing we want to do is try to do this without our calculator. So without my calculator, often you have equations that you can solve as long as you can write the two bases. So look at that first question. Which numbers are the bases? 3? And actually 1/9 we could write as a base to an exponent. How could I rewrite 9 as a base of 3? Or as 3 to an exponent? Yep, 3 squared, and I heard some people already kind of go into the next step. So if I look at this as, I'm going to do a little thought bubble. This is really 1/3 squared. If I can write both of the sides of the equation as the same number to a power, I can solve this without a calculator. So 1/3 squared, I heard Christian say it. Christian, how could we rewrite that as just 3 to a power?
3 to the negative 2.
Awesome, 3 to the negative 2. Looking at the other side, I already have 3 raised to the 2x minus 3. Now, when the bases are the same, the exponents have to be the same. 3 squared cannot equal 3 cubed. 3 squared could only equal 3 squared. So when the bases are the same, the exponents are the same. So if you can get those two numbers, which we just did, 1/9 we wrote as 3 to the negative 2nd, if you can get them to match the same base as the other side, then you can just set the exponents equal to each other and then solve for x. So this is a nice kind of easier way, and we always want to try this way first because we kind of want to use that calculator as a last resort. So I'm going to add 3 to both sides, which gives me 2x is equal to 1. Divide both sides by 2, and that gives me x is equal to 1/2. Now I could check it, plug it in. 2 times 1/2 is 1. 1 minus 3 is negative 2, and 3 to the negative 2 is 1/9. So that works. All right, let's try another one. Again, the goal is going to be to try to get both of those numbers written as just the same value to a power. So if I look at 49 and I look at the square root of 7, well, let's start with the right side of the equation. How could I write the square root of 7 as just 7 to a power?
7 to the 1/2.
Yeah, 7 to the 1/2. You guys know that square root's the same as the 1/2 power. Now, how could I rewrite 49 as 7 to a power? 7 squared, good. So I'm literally going to replace it like that. And then I still have this being raised to the x minus 2 power. Now, in order to simplify this, I do need to recall a rule. So I'm going to do like a little thought bubble off to the side. When you take an exponent and raise it to an exponent, do you add, subtract, or, Liana?
Don't you multiply?
Multiply. So it's going to be a to the m times n. So this is actually going to be 7 raised to the 2 times x minus 2 equals 7 to the 1/2.
That'd be, no.
You might be ahead of me. What type of property am I going to need to use with this too? Distribute, awesome. So we have 7 to the 2x minus 4 equals 7 to the 1/2. Now that the bases are the same, the exponents have to be the same. So I'm going to go ahead and set 2x minus 4 equal to 1/2 in order to see, well, what would x have to be? So 2x minus 4 equals 1/2. And now I just need to solve for x. So I need to add 4 to both sides. And that gives me 2x is equal to, I'll just call it 4.5 or 4.5. And then we divide both sides by 2. And 4.5 divided by 2, I believe is 2.25. 2 1/4 works. Yeah. And that's our answer. Leanna.
So this is more of like an observation, and maybe I just want to make sure I'm doing it correct.
Yeah.
But so basically, when your bases are the same, they in a sense like cancel out.
Yes.
Okay. I
Yes.
just want to make sure.
And then guys, I want to give you one more to try on your own. So think of this as like a letter C. If I give you 9 to the x minus 1 is equal to 27. See if you can try that one. 9 to the x minus 1 is equal to 27. I'm going to do a quick walk around, see if we're kind of starting in the right place. All right, guys, some of us are a little stuck. Some of us figured out what is the base. Let's see here. Emily, can you tell me what base did the number 9 and 27 share? 3. 9 is the same as 3 squared. 27 is the same as 3 cubed. So if I replace 9 with 3 squared, I have 3 squared to the x minus 1 equals 3 cubed. Now, what property do I need to use with this 2? Distributive. So this will become a 3 to the 2x minus 2 equals 3 cubed. And then if you heard what Liana said, if the bases are the same, you can basically take them away. And I get 2x minus 2 equals 3. I'll add 2 to the other side, and I get 2x equals 5. And then I divide both sides by 2, and I see that x is equal to 5/2. Any questions on that? Okay, you have some practice of those in the homework because it does take kind of some practice before you can really figure out what base do they share. But typical bases are 2 or 3 or 4. All right, the next thing we look at is what if we can't make both sides of the equation the same base? That's where we then need to bring out the calculator. We already did these type, but this is just a review of, hey, when would I need to do this type? So the first thing to do always, and you guys did a few of these on the warm-up quiz, is to isolate the exponential function. I love that a lot of you are taking out your calculator. Go ahead and take out that calculator. You will need it. I'll even open mine so it doesn't take forever. Okay, this is review. So second, transform the function into log form. Quick reminder, if a to the c equals b, then log base a of b equals c. Third, solve for the variable. Note, leave your answer in log form if the exact answer is desired, or use your calculator for an approximated decimal. Let's do both so we just can make sure we know how to do both. So looking at this first equation, which one's the base? 8. We need to isolate that guy first. Isolate the base. So this plus 2, what do I do with that guy? Subtract it, awesome. And I get 8 to the x is equal to 3. Now here is going to be a big theme today. If you're stuck in one form, convert it to the other form. So I'm like, I'm stuck. X is in the exponent. I can't divide by 8. I can't square root 8. So I'm going to convert to log form. In doing that, I would have log base. What would be my base? 8 of 3 equals x. Now this is exact, so I would say, hey, I'm going to box that if it was asked of me exact. If I was asked to do it on the calculator, what buttons do I press? Alpha, window, good, option 5, awesome, and it's log base, what was it, 3 of 8? Yeah, or 8 of 3. Log base 8 of 3 gives me 0.5283. 0.5283. Do you guys remember, so this is approximate. Do you guys remember how to check your answer on the calculator? This is super helpful, especially for tests. I could just plug it in for x and say, is 8 raised to the, did you guys know that you could arrow up and reselect an answer that you've done in a previous line? Hopefully you know that it can be helpful. So 8 raised to that answer, get out of that exponent, plus 2 gives me 5, which yes, that is what is on the other side of the equation.
Yeah, I got a different answer.
Liana?
So on the calculator, so I saw when you highlighted it, did you just press enter and then,
Yes,
okay.
yes. Charlie, sorry, what was the question?
I got a different answer.
For log base 8 of 3?
Yeah, I got negative.
So I'll come to your calculator and see what you're typing in. For right now, guys, if you could turn to your partner, this is 2 times 6 to the 3x minus 1. Turn to your partner, and I'd like the person with the lighter colored shirt to tell them what you would do first.
I'm gonna read this back. And then very close to it.
Oh, you're doing a lot.
Yeah, that's the only step I can think of. How I started is I added 4, just to get that out of the way, and then would you divide it by 2? Yeah, that equals 8, and then I divided by 2,
Yes.
and I had 6.
Oh, because you wrote log base 3 of my question. Log base 8 of 3.
4.
Because this guy, the one who told me about the exponent, I don't know how many of these guys say.
Cube to 3x minus 4 and then 2.
Put this guy down in the base.
So it looks like,
2 cubes.
or yes, and then 4 would just be.
Well, yeah,
What?
2 times 3 is 6.
You're correct.
I don't know what number.
All right, guys, I feel like it's getting close to lunchtime. We might be getting hungry. So I've got mini M&Ms. For you and your partner, raise your hand if you can tell me, how do you do this problem? Ezra, what do we do first?
So I started by adding 4.
Beautiful. So then you had 2 times 6 to the 3x minus 1 equals 8. Awesome. What did you do next?
Divide by 2.
Beautiful. Guys, notice he's getting that base by itself. The base is 6. So we have 6 to the 3x minus 1 equals 4. What did you do next?
I put it in the log form.
Nice. He converted it. So what did your log look like?
I got log base 6 of 4 equals 3x plus 1. Or minus.
Perfect. Minus 1. Where'd you go from there?
I added 1 to the log.
Awesome. So we would write this as log base 6 of 4 plus 1 equals 3x. And what's the last thing that you did?
Then I divide double 1.
The whole thing by 3. Excellent. You and Min are going to get some mini M&Ms in just a moment, but I want to make sure we all know how to plug this in on our calculator. So on the calculator, how do we enter in a fraction? Good. Alpha y equals, and then I'm going to type in that log. So I have to press alpha window, option 5. It's helpful if I can see the problem. It's log base 6 of 4. Log base, oops, there we go, 6 of 4. I need to get out of those parentheses because I'm going to add 1 to the log. And then divide it by 3. And that gives me, I want to make sure I type that in correctly. That gives me an answer of 0.5912. 0.5912. All right, nice. Okay, guys, that's a review of how to solve exponential equations. Emily?
Will you have her check that?
Yes, I will show how to check that. Good question. 0.5912 would be the answer rounded to 4 decimal places. Emily's asking, can we check that? Which this is a great thing to check, especially because there's so many steps involved. So I'm going to go this answer back into the original. So I would do 2 times 6 raised to the 3 times that answer. So again, to reselect that answer, I press second negative minus 1. And then I get out of that and subtract 4. And I want to see, does it equal 4? And it does. So I know that, oh, sweet, that's the right decimal. I didn't make any mistakes in my math because there were so many steps and it's easy to make mistakes. Does that, did you raise it to your answer? Let me expand that. 3 times the answer. The last thing we need to take a look at is solving logarithmic equations. And before we can do this, we really need to determine when can log equations not be solved. So looking at this question, which of the following cannot be solved? Let's think through these. Looking at number 1, if I'm asking, I don't know why my computer's doing that, 5 gives me negative 15. Well, what's 5 to a negative exponent? It's a fraction. 5 to a negative exponent is a fraction. 5 to the 0 equals 1. 5 to a positive number equals a really big number. So can this ever equal a negative? No. So no, this guy cannot be solved. Could we plug this one into our calculator, log base 2 of 15? We could. 2 raised to a power will give me 15. If I plug in log base 2 of 15, I will get an answer. So that one can be solved. In fact, if I don't even want to think through it, I could just plug it into my calculator and say, what's log of 0? And in my calculator, it should tell me if it works or not. So if I'm asking, what is log of 0? It'll say error. The reason it's an error is because if you thought through it algebraically, what's the base here? There's no base written. 10. If I'm asking 10 raised to what power equals 0, nothing. 10 to a negative number gives me a fraction. 10 to the 0 gives me 1, and 10 to a positive number gives me positive. So 1 and 3. So what do you think goes in these blanks? You can never take the log of a negative or 0. Awesome. Okay. Log equations. I love log equations. I think as long as you know the transformation, you're set on solving that. But there's 3 major steps you kind of want to keep in mind. Letter A, isolate the log. This can mean using properties if you need to. So letter A, isolate the log. Use properties if necessary. Number 2, letter B, convert to exponent form. And then finally, letter C, get x by itself. So isolate x. Isolate x. Those are your 3 basic steps to being successful in solving log equations. Now, sometimes I get some confusion on what does it mean to isolate the log. As long as the log has a subscript and a value. It's isolated. So as long as the log has a subscript and a value, it is by itself. So this is an example of an isolated log. Isolated log. Number one I have equals -1 is isolated. It's already by itself. So letter A is done for me. What would letter B be? Go back and read it. Convert. So let's think about how we convert it. So now I'm going to convert to the other form, exponent form. Which one's going to be the base? 4. Go around the world. What is it raised to? -1 equals 5x. Perfect. We can't have a negative exponent. What's 4 to the -1 equal to? Yep, 1/4 equals 5 times x. And now you could take 1/4 and divide it by 5 on your calculator if you want, or you could remember that you can multiply by the reciprocal of the number. This is kind of an algebra 1 refresher. If this is 5/1, we could multiply it by 1/5. Do you guys remember that from algebra 1? And then 1/5 times 5 cancels out. But now this is easier for me on the other side, because what's 1/4 times 1/5? 5 times 4 gives me 20, so 120. Now you guys, you know me, I love the check step because I make mistakes, it just happens. So if I'm looking at how would I check this, clear out of that, then I would go ahead and plug in log base 4 of 5 times 1/20. So I would do alpha window option 5 and say what's log base 4 of 5 times 1/20. So I can do alpha y equals, enter in 1/20, press enter, and it's -1. Is that what the problem said it should equal?
Yes.
Awesome. So I know I've done it correctly. Leanna.
So I just want to make sure on the part like where you have the 1/4 and the 1/5, which one do you do first? Like, so do you get the 1/4 first and then?
Yeah, so we make this into a negative, because it has a negative exponent, I make that into a 1/4 first.
Okay.
Then I want to undo the times by 5, so I times it by 1/5.
Okay.
All right, on to number 2. Number 2, there's no base. What's the base?
10.
10, love it. Is the log by itself? Yeah, I have log base, a number of a number. So what's the next step? What's step 2? Convert. What's the base of the exponential equation? 10 raised to what power? Equals 3x minus 5. It's a big one, but it's doable. Okay, what is 10 squared? 100 equals 3x minus 5. Now you guys know how to get x by itself. What undoes subtraction? Addition. So we're going to add 5 to both sides, giving me 105 equals 3 times x. What undoes multiplication? Division. So we're going to divide both sides by 3. I think this is actually doable. 105 divided by 3. What is it, 35? Thank you. And there's my answer. Not too bad, right? Just get the log by itself and then convert, and you're on your way. All right, let's go try another one. Number 3. Number 3, actually, I'm going to ask you to turn to your partner, and this time, the person with the darkest hair in the group. You start it.
Okay. So we're gonna have x to the 0, 5 equals 10x minus 3. Then you would equals 10x. You would add 3 to the other side. And then since 5 times 0, it would be 1. So it would be then have that set up a little bit, 4 to the 10. Because you divide by 10x. And then simplify that, and then you would add this to the other one.
You're good.
Then you add 3 videos. So it's 4 plus 10x, and you just divide.
All right, it's getting closer to lunch. We might be getting more hungry for another set of mini M&Ms for you and your partner. Raise your hand if you can tell me, how do we do this problem? Charlie,
Okay, so it's already, you don't have to, it's already on its own. I can't remember what the word.
awesome, it's isolated, awesome.
And so 10x 5 to the z, you change it to excellent form, so 5 to the 0 equals 10x minus 3.
Perfect.
5 to the 0 power is 1. 1 equals 10x minus 3, and you have the 3. And that's 3 or 4 divided by 10, and then that's 2 fifths.
Woo, that's awesome. 4 divided by 10, you said was 2/5?
Yeah.
Awesome, because we can divide by 2, divide by 2. Well done. Class, any questions on that one? All right, number 4. Number 4, remember, sometimes you might have to use the properties of logs. Do you think we'll have to use the properties here? Yes, we have 2 logs, and I need to isolate it into 1. What can I do with the minus sign? Division, good, the quotient property here. So this is actually log of x divided by 5 equals 3. There's no base. What's the base understood to be? 10, good, so go ahead and draw that in. Now, is the log by itself? Yep, so what form are we gonna, or what are we gonna do next? Good, put it in exponent form, convert. So I have 10 cubed equals x over 5. What is 10 cubed equal to? 1,000. Now I need to get x by itself. X has been divided by 5, so what undoes division? Multiplication, wonderful. Multiply both sides by 5, and I have x is equal to 5,000. All right. Number 5. Number 5, the log is definitely not by itself. I'm combining. Which property do you have to use first if you're combining? Power, good. Where do we see the power property here? Excellent, the 2 before the log. We need to bring that back up to the power of x. So that's log base 3 of x squared plus log base 3 of 5 equals 2. Now what property is going to bring them together? Product, good. Multiply those 2 together like you guys did on that warm up. So we have log base 3 of x squared times 5 equals 2. Now I'm stuck. This x is part of the log. I'm stuck. Convert it. Excellent. Convert. And so we have 3 squared equals 5x squared. 3 squared gives me 9, so I have 9 is equal to 5x squared. We need to get x by itself, so what undoes multiplication? Division, so we're going to divide both sides by 5. And that gives us x squared is equal to 9/5. What undoes a square? Square root. What do I need to keep in mind when taking the square root?
Plus or minus.
Plus or minus, awesome. And if you're square rooting a fraction, you have to square root the top and the bottom. Here's some free final review for you. Square root of 9, what is that? 3. So this is plus or minus root 3 over root 5. What if on the final you're asked to rationalize the denominator? Do you remember how? What do I multiply this guy by? Root 5, good. Root 5 over root 5. So this is, oh, and I called that root 3. Sorry, that should have been just 3. Because the square root of 9 is just 3. So this is plus or minus 3 root 5 over 5. Some free final review for you. You will be asked to rationalize the denominator in the final. Now, there's one last thing I need to keep in mind. I technically should always check with logs. So let's think about this. I have a positive and a negative answer that I'm plugging in for x. Which one should I throw away? I have the negative. Why should I throw away the negative?
Earlier we said you can't log negative.
Excellent. You cannot log negatives. So throw that negative away. And it's just 3 root 5 over 5. All right, we're going to do one more together, and then I'm going to have you try 2 on your own. And if you get these 2, then I'm going to have you just start the homework, maybe finish it before the weekend. Number 6. Ooh, logs are on both sides of the equation. I need to isolate just one. Any ideas?
Well,
Emily? Yeah, let's subtract log of x minus 5 to both sides. I love that idea. That gets rid of this one. And that gives me log of 2x minus 3 minus log of x minus 5 equals 1. That feels much better for me because I know a property that involves subtraction. What can I do to bring those 2 logs together? Quotient, yeah, divide. So I'm going to have log of 2x minus 3 over x minus 5 is equal to 1. There's no base. What's the base understood to be? 10, love it. Now I am stuck. There is nothing more I can do with this log. Convert. Maybe that's why I love logs so much. Maybe I kind of relate it to my life when I was stuck in sin and I just couldn't do anything. And it was like, what do? Jesus gave me a way to redeem. And I confessed my sins to him and he converted me into a brand new person. And I'm telling you guys, there is no better life than with Jesus because I've never had more joy than I do than when I changed my life for him. So let's go ahead and convert 10 to the first equals 2x minus 3. You still don't like logs, Sergio? Over x minus 5. That's okay. Hopefully you know.
Like Jesus.
You do like Jesus? That's good. That's really good. All right, so we've got 10 equals 2x minus 3 over x minus 5. And now I need to get x by itself. What do I do? Well, x is in the denominator, x minus 5.
oh,
So could we multiply it out?
yeah, I was gonna say, yeah.
You were going to say reciprocal?
Yeah.
That would be good. Think of it as x minus 5 over 1. So then that reduces. This is probably the hardest type question you would see, but I know you guys can do this. We would multiply that out. What property would I use with the 10? Distribute, love it. So I have 10x minus 50 equals 2x minus 3. Oh, that equation feels so much better. What are we going to do to solve now? Just get your like terms together. Get x by itself. So subtract 2x, which gives me 8x minus 50 equals negative 3. Add 50, which would give me 8x equals 47. And divide by 8. Woo, x is equal to 47/8. That was a lot of steps. Is it possible that I could check this one? We can. We'd have to plug that in twice on both sides of the equation. Just make sure both sides of the equation are equal. Let's go ahead and check that one just to make sure. Oh, my calculator froze. Come on, calculadora. Don't take so long. Okay. All right, so I've got log of, and the nice thing is when there's no base, guys, the base is 10, you can just press the log button. That's right to the left of the number 7. So I have log times 2 times alpha y equals, what was my answer? 48/7?
Yes.
Okay.
Oh, 47 over 8, sorry.
Oh. Okay. Log, oh no, and now I'm 2 times, I need to make sure I press times, you said, sorry guys, 47 over 8?
Yep.
Love it. So 47 over 8, and then minus 3, and I get an answer of weirdness, but I just need to make sure that that weirdness is the same on the other side of the equation. So I'm going to go ahead and on the other side type in log of that answer, which you guys said was 47 over 8 over 8. And then I have minus 5, close the parentheses, plus 1. And yes, the same weirdness. So I know that I have it correct because the one side of the equation equals the other side of the equation. Okay, here's what we're going to do. I'm going to ask you to solve number 7 and number 8 on your own. Oh, wait, what did I do with number 7? Actually, no, I thought I changed. I think I meant to put an X in a different place. Guys, this one should be easier to solve, number 7. Anyone know the answer to number 7? 2, because if you're stuck in log form, change it to exponent form, and that would be 5 squared. But this takes us back to the beginning of the notes. You can make 25 the same base as the other side, and then you can see that X has to equal 2. So let's just finish this one together. Number 8, if I'm asking 125 raised to what power gives me 5, you could try to not reach for your calculator. How could we rewrite 125 as a base of 5? 5 cubed, excellent. And if I have 5 cubed raised to the x equals 5 to the, what's the power on 5 if there's nothing there? 1, good. So this is actually 5 to the 3x equals 5 to the first. And now you can set 3x equal to 1 and solve. And you get x is equal to 1/3. All right, you have 25 minutes. I would strongly suggest you to take advantage of this time, work on that worksheet, get a good chunk done so you don't have much over the weekend. And then you guys have a great weekend. So I'll give you some time to work. Let's see if my YouTube thing actually works.